Hello, my good friends. I hope you're doing great. We are going to do some fun stuff today. So you might be watching this because we did in class. You're like, man, I really just need a refresher. That's great. Maybe you missed today in class. Oof, tough break there. Anyway, we are factoring trinomials. If you are a mental math, like, hey, I'd love to figure out what numbers multiply to this, today is finally your day. If you're not, hey, no big deal. You'll get more comfortable with these as time goes on. So let's dive right into it. We're all about factoring trinomials today. So remember when we FOILed, we had two binomials? This is basically the opposite of that, right? We don't really call it division, but in essence, that's kind of what it is. Okay? All right, so here's our two trinomials. We're going to go through, as you can see, 9 pages worth of good stuff today. So here's what we do. Good news, when there is a coefficient of 1 here, right, invisible 1, we just look at our back number here, right? This is 12. So I want to come up with all the factors of 12 that I can think of, okay? Now remember, we want it to be positive 12. So in order to get a positive 12, we could multiply two positive numbers together to get 12, or we could multiply two negative numbers together, right? Like negative 1 and negative 12, okay? Anyway, I'm just going to do the positives for now. I like to put the little signs with them, okay? Because I want to come up with all of the factors of 12, right? So 1 and 12, 2 and 6, 3 and 4. That's really it, right? I could go and write negative 1, negative 12, negative 2, negative 6, negative 3, negative 4, because those indeed multiply to give me 12. Now, I want to look for which pair of these will add up to positive 7. That's why I wrote the signs with them. And it's this pair right here, okay, 3 and 4. So here's what we do. I literally just want to rewrite this middle term with these two right here. So I'm going to say plus 3x plus 4x, okay? Bring x squared down. Do the same thing with your 12, okay? Now what does it look like? Just what we had the other day, right? Factor by grouping. And that's what we're going to do. We're going to group these together. We're going to group that together, right? Greatest common factor. Only thing I can factor out here is an x. This will turn into x plus 3. I need to factor out a 4 here. This will turn into x plus 3. All right, go ahead, write your two binomials. And you are done. Yes. Okay? So, look, I want to be honest with you guys. There are many ways to factor, okay? There are many methods to do this, okay? This method always works, okay? We could do guess and check, right? We could do an X out method. There's all kinds of weird stuff that all kinds of smarter people than me have made up, right? This is one that has worked really well for us in years past because it always works. Even if they put a number in front of x squared, like a 4, right? 4x squared or something like that, okay? All right, on to this one. Same thing, all the factors that multiply to positive 2. Well, again, this one's easy. It could be positive 1, positive 2, because there's not a lot. I'm going to write the negatives up here. Now, which one of these will add up to positive 3? Okay, yep, you figured it out. It's this one. Again, replace this middle term, right? This middle term with these two here. So this is going to be plus 1x plus 2. I know what you're thinking. Does it matter the order that I write them in? Could I have written the 2 first and the 1? Sure. That's the cool thing. It really doesn't, because once again, we're factoring with grouping, right? And as we have figured out, I'm going to factor out an x here. It doesn't really matter, right, what we do, right? As long as we make these two match, we are good to go. X plus 2 is one binomial. X plus 1 is the other one. Bam, good to go. Okay? Again, factor by grouping when we make it here. Okay? I know what you're saying. Doesn't seem so bad, right? And in some cases, guys, they're not. In other cases, we're going to get like here. Right? What do we notice here? Right? The signs in these trinomials tell me a lot. Minus, plus, right? That one's the same thing. So this says I'm looking for two numbers that now multiply to 27, right? Positive 27. At the same time, they will somehow add up to negative 12. I know all of you are scrambling through your brains to try to figure out what the pair is before I write it up here, and that's fine. Okay? So how are we going to get two numbers to multiply to a positive, but when we add them, they add up to a negative? Somebody out there said it. Yeah, they both have to be negative numbers, right? That's the only way. Two positive numbers would add up to another positive. However, two positive numbers clearly, or two negative numbers clearly would add up to a negative, okay? So what I mean by that, right, if you haven't figured it out, right, so plus 1 and 27, right, these are two positive numbers. It works here, but you're never going to get two positive numbers to add up to a negative, okay? So we know we got to be negative here. So I'm sure you guys have all figured out that it's 3 and 9. All right, so negative 3, negative 9 is the pair I'm looking for here. Again, it doesn't matter what order we write those in. Negative 3x, you've got to make sure you write this x here. Minus 9x plus 27. The first and last terms don't change. If you write these as minus 3 and minus 9, there's no chance of us getting this right, okay? We are just rewriting this term, right, with these two here. This term has an x, therefore these two have to have an x, okay? Group it. All right, be careful, we got a negative here. So I'm going to go x, and this is going to turn into x minus 3. I'll take out a negative 3. No, I'm not going to take out a negative 3. We're actually going to go for a negative 9, people. And that'll turn this into x minus 3. Okay? Bring everything together, x minus 9, x minus 3. That's what we're looking for. Okay? Good to go? Show you guys, I'll switch colors here. Same thing here, right? Same structure. Again, we're going to do these one at a time. They're going to seem easy, right? Kind of like our exponent rules. We did them one at a time. They kind of seemed easy. Then we do all these together. They get all jumbled up, okay? All right, so same structure. We're going to look for two negative numbers that will add up to negative 10 that also multiply to multiply to positive 16. It's early in the morning here, folks. Okay? So 16 doesn't have a lot of factors. Negative 1. Negative 16. I do not want the green color, folks. There we go. Negative 1, negative 16, negative 2, negative 8, negative 4, negative 4, right? Only one of those works. Happens to be that one right there. Can you guys even see that? Probably not. Okay, rewrite the middle term. Just because I'll be different, I'll go minus 8x, then minus 2x, and then plus 16. All right, factor by grouping. Yeah, it shows up okay. This will turn into x minus 8. Probably need to take out a negative 2 here to get this to turn into x minus 8. Again, if you only factored out a 2 here, this is going to turn into x plus 8. I'm sorry, negative x plus 8, right? Which is not the same as this. So when these don't match, we have to go back and figure out what to factor out to make them match, okay? Again, that's stuff that we did before, so we should be awesome at factoring by grouping. If not, go back and check that out. Again, there's my answer right there, x minus 2 and the quantity x minus 8. Is that the right answer? Any way for me to check that, folks? What do you think? There's always a way. Just FOIL it, guys. FOIL it and see what happens, right? Does that turn back into the trinomial that we started with? Good news here. We still have coefficients of 1. These are the easiest ones to do, okay? Why? Because the factors aren't nearly as big. So here we go. So now we're looking for numbers that add to 3, multiply to a negative, okay? These are probably the trickiest ones. Well, why are they tricky? Well, we multiply to a negative. The only way that can happen in the whole history of math is if I have one number that's positive and one number that's negative, okay? So one number positive, one number negative. In this case, then they're going to add up to 3, to positive 3. So remember, we had a negative number and a positive number. And when we add them together, we get a positive number. So that tells me the bigger number, the larger number has to be the positive number, right? Because when we add the smaller one to it, it will still be positive, right? When we add the negative number to it, I should say. Okay? So here's what that looks like. So factors of negative 18. So like I want negative 1 with positive 18, right? Here's what I'm talking about. These would multiply together to give me negative 18, of course. And when I add them, they add up to positive 17. Well, I'm looking for positive 3, right? But do you see how the positive number will make this middle term positive, okay? So we're going to keep going here. So this is going to be negative 2 with positive 9. I could have negative 3 with positive 6. And those are all my factors of 18. Obviously, this is the one right here we're looking for, negative 3 and positive 6. All right, once we find it, we are home free. Negative 3x plus 6x minus 18. Factor by grouping. Love factoring by grouping. All right, x, this turns into x minus 3. We're going to factor out, how about a 6, folks? That will also be x minus 3. Okay? Does it matter the order that you write these two binomials in? Plus 6. Absolutely not. Okay? I could have wrote x plus 6 first, x minus 3 second. It's multiplying, guys. 2 times 5, same as 5 times 2. Okay? Good to go here? All right. This beauty over here, all right? We're going to multiply to negative 20, add up to negative 1. Ooh, okay? Kind of the opposite scenario we have from that one. So we're multiplying to a negative. That hasn't changed. But now we're going to add up to a negative. So it's going to be like flip-flopped. Again, the bigger number, right, will have that sign. It'll be negative, okay? So we could have positive 1 with negative 20. Of course, that doesn't work. Positive 2 with negative 10. Positive 4 with negative 5. There it is, okay? There it is. All right, go ahead and rewrite everything. So x squared, I'll say plus 4x minus 5x minus 20. Time for some grouping. This turns into x plus 4. We're going to factor out a lovely negative 5 here to turn this into x plus 4 as well. And we are all set. X minus 5 times the quantity x plus 4. Bam. Okay, so those are the super straightforward examples, guys, in here. Again, as you can tell, it takes a little bit of time to get through these. All right. Due to time constraints, no, we're going to do these ones because these ones are a smidge different, aren't they? Nah, not really. These are just like the other ones that we had. Okay, there we go. Why are these ones different from those ones? Those ones? Different ones. Why are they different? That's right. This makes our life more annoying. I gotta be honest with you, folks. It really does. There's 2 ways we can handle it. We'll tackle it the first way, and then on letter B, I'll do something different. Well, because we can. All right. So the first thing we want to look for here, is there a greatest common factor? So I could actually make these numbers smaller to make my life easier. 5, 27, and 10. Nope, sure isn't, right? If this was 25, we'd be home free, but it's not, okay? So here's what we got to do. Now I need to multiply, right? Because I'm not looking for just factors of 10 here. I don't know who figured this out, but they're pretty smart. 5 times 10, guys, is 50, right? In this case, positive 50. Those are all the factors I want to look for now that will add up to 27, okay? I know some of you are already going through your brain. Remember, so it's multiply to positive 50, add up to positive 27, right? So 2 positives or 2 negatives could multiply together to give me this, but only 2 positives will add together to give me this. So everything's going to be positive. So in other words, we could have like positive 1, positive 50, positive 2, positive 25, positive 5, positive 10, right? And of course, all you were yelling, I could hear you. Hey, stop, there it is. Yeah, so 27 and is the 2 and 25 one, okay? Now, be careful. When I go to rewrite this, just as we've been doing, the only thing that changes is 27. You leave the 5 and the 10 alone. You hear me? You do not make this a 50. That will lead us down the wrong path of factoring. So 5x squared, let's just say plus 2x. Plus 25x plus 10, okay? So again, 5x squared stayed here, 10 stayed here, just like we've been doing. We just replaced middle term with our 2 factors, okay? Now it's time for some grouping. Nothing to do here but an x. This will just turn into 5x plus 2. Yep, I can factor out a 5 here, and this will turn into 5x plus 2. And that's so cool. Like, that's just always amazed that this still works. All right, and x plus 5. Not sure if that's the right answer, folks. Check your work, foil it out. Go for it. It's going to work, trust me. All right, this one here. Okay, 4 times 32. What's 4 times 32? Well, 128. Are there a lot of factors of 128? Yes, there are. Okay. Wouldn't it be great if I could make this smaller? It would be. 4, 24, 32. Do they have a greatest common factor? Mm-hmm. Happens to be a 4 in this case, right? So when you can do that, my friends, go ahead and factor out a 4, right? Or a greatest common factor. Because now, Adobe wants to update. Guess what? Flash doesn't exist anymore. Hold on. Yeah, I got you. There you go. Okay. All right, guys. So, look, this turned into one of the basic trinomials that we could do before, right? This was easy, okay? So anyway, so I'm going to fast forward here. I've been factoring forever. I know this video is dragging on, right? This is going to factor into x plus 2 and x plus 4, okay? But we've got to make sure that we have this 4 here, okay? If you don't have that 4 there, you're not going to have the right answer because, guys, I'm telling you right now, this doesn't factor into this. But if we have the 4 there, it will, okay? All right, so there we go. That's good. What else we got to do here? Okay, again, same thing. We're still looking for that greatest common factor. 3, 26, 35. We don't have one there, okay? Okay, so we're going to have to go a times c, right? If you think about our standard form, guys, ax squared plus bx plus c. A lot of people will say a times c because that's what we're doing, okay? So 3 times 35, what is that? 90 and 15, 105. So we're looking for numbers that multiply to 105. At the same time, they're going to add up to 26. I don't even know the factors of 105. Thankfully, I found one of these laying around here somewhere. I wonder what 5 is, right? And this is really, guys, this is the only guess and check part that we have to figure out. So, again, we're adding up to a positive number. We're multiplying to a positive. That means both of them will be positive. So, positive 5 and positive 21 is the pair I'm looking for here. Okay? And if you want to, you know, like, hey, I know 3 and 5 aren't factors of each other. 3 and 21 could be. So maybe I choose to write that one first. 3x squared plus 21x plus 5x plus 35. It really, again, I said it 1,000 times, doesn't matter when we go to factor by grouping what factor is first. This is going to turn into x plus 7. I'm going to factor out a 5 here. This will also turn into x plus 7. So 3x plus 5 and x plus 7. Fantastic job. You guys are doing a great job, by the way, okay? Can I factor out a number here? Sure can. 2. If you don't factor it out, will you get the same answer? Well, mathematically, yes. It's going to look a little bit different, and that's okay. All right? But we're going to factor out a 2, and we're going to say x squared plus 7x plus 10. Okay? Again, due to time constraints, I'm going to go ahead and factor this with my brain here. This is going to be x plus 5, x plus 2. Okay? So, you know, if you didn't factor this out, okay, the 2, right, your answer might look like this. Okay? Or it could look like this, x plus 5 and 2x plus 4. Okay? All 3 of these are correct answers. Isn't that crazy? Okay? So anyway, there we go. We're getting onto the end here, I do believe. Factor this. Okie dokie. All right, greatest common factor here. Nope. Same process that we did before, right? 24 times 3, what is that, 72? Gosh, I hope so. 60 and 12, yeah. So 70, so okay, so we're going to, all right, so we're going to multiply to 72, positive 72. But we're going to add up to a negative 22. Okay, interesting. So guys, that tells me, right, like when this is a really big number here, like think about what that means. That means that your two factors aren't going to be very close to each other, right? It's not like, hey, 72, we're all thinking 9 and 8, right? But 9 and 8, if you had negative 8 and positive 9, they're only going to add up to 1, okay? Because they're just one, right? One number apart. So we're looking for numbers really that are 22 places apart, okay? So anyway, so we can go through all of our fun stuff here. Let's see. I think it's this one right here. No, it's not. Is it not that one? Hold on, folks. Got it? Okay. Yep. Okay. All right. Well, interesting things have happened here, haven't they? Okay, let's go through all the factors here together, okay? So remember, multiply to here, add up to a negative. So the bigger number is going to be the negative 1. So positive 1, negative 72, right? These would still, wait a second. Wait, we are way off here, people. I've been lying to you this whole time. Why hasn't someone yelled at me? These both have to be negative. We're going to add up to a negative number here. No idea what my brain was thinking there. Anyway, okay, so I backtrack. So now we're at negative 1 and negative 72, right? Yes, these multiply to here, and they do not add up to this right here, okay? So we can keep going. Negative 2 and negative, 36? That doesn't work. Negative 3 and negative 24, okay? Negative 4 and, what is negative? That's 4 and 18. Aha. Stop right there. Okay. Whew, now we're good to go. See, I haven't drank my entire coffee yet, guys, so you got to bear with me. All right, here's our magical pair. 24x squared minus, sure, we can go 4x minus 18x plus 3. Time for grouping. Okay, I'm going to factor out a 4x here. This will turn into 6x minus 1. We are going to factor out a negative 3 here to get this to turn into 6x minus 1. Okay, is it wrong if you factored out a negative 4x? No. Okay, it's going to change the way everything looks, but at the end you're still going to get the same thing, okay? All right, so 4x minus 3 and 6x minus 1. After a rough start on that one, whew, we finally made it. Okay. You guys want me to do this one? I don't know, why not? Same thing here. 120, right, is our number we're looking for. At the same time, we are going to add up to negative 23. Okay, so same thing is happening, right? There's got to be two numbers that add up to negative 23 that multiply here. Can you figure out what they are? I clearly can't because my brain is not working yet, right? I'm sure somebody out there has figured it out. But like negative 1 and negative 20, no, 120. Negative 2 and negative 60, negative 3 and negative 40, negative 4 and negative 30, negative 5 and whatever this is. I think this is going to be our magical pair. What? Calculator work. 24. Nope, sure didn't work. Negative 6 and 20. Well, there's a lot of factors here, aren't there, right? Let's see. Aha, there it is. Negative 8 and negative 15. Well, that took a while. And that's really, guys, the only annoying part about this is finding the right pair. Okay. Once we have that, we're good to go. So we have negative 8, negative 15. I'm going to pair up the 15 and the 10 here. So we're going to go 10x squared minus 15x minus 8x plus 12. Okay, factor by grouping time. It's a very large, aggressive parenthesis here. Okay, factor out of 5x. This turns into 2x minus 3. Going to factor out of negative 4 and get this to turn into 2x minus 3. And now we're home free. Boom. 5x minus 4. Great. Good news, folks. It took forever in a day. We are on the last one. Okay? All right. Greatest common factor there? Nope, sure isn't. Right, go ahead and multiply these together. So negative 15. Let's see what the middle one tells. So we're going to add up to a positive number. Okay, so obviously if we multiply to a negative, one's positive, one is negative. You're right, you're with me there. And now we want the bigger one to be positive. Okay, so like I could have negative 1 with positive 15, right? That multiplies to here. It would add up to, what, 14? Okay, so that doesn't work. 2, no, negative 3, positive 5. And those are it, right? I mean, 15 doesn't have a lot of factors. 1, 15, 3, and 5. Unless I'm missing something. Somebody yell at me. Does this add up to this? No. Okay. So, when things will not factor, that's our fancy word for will not factor, right? Some people write unfactorable. Okay, that's true. It is unfactorable. We say it's prime, right? Kind of, like prime numbers. Okay. So anyway, so yeah, this makes Optimus really happy because we didn't have to do a lot of work here. We just wrote prime there. What about this one over here? 3 and 3. So this is gonna numbers that multiply to positive 9. At the same time, they add up to negative 5. So we're multiplying to a positive, so 2 positive numbers, or we could have 2 negative numbers, which are what we want because they're going to add up to a negative. So negative 1, negative 9 would clearly multiply to a positive, but not add up to that. Negative 3, negative 3, right, so that would be negative. If this was negative 6x, we could factor it, but it's not. It's negative 5x. So once you've gone through all of your factors, right, and none of them match up, that's how we know it's prime, okay? So we'll see these every now and again, right? They'll bebop around and be frustrating because they're there. But in the meantime, guys, there's our introduction to factoring trinomials. We had some basic trinomials in there. Those are the ones that had coefficients of 1. And then we had some more challenging ones that had coefficients, right, like we saw here that were actual, numbers, and it was good stuff. So anyway, hope that helps. Have a great day. Good luck factoring.